Hello, this video will focus on geometric sequences. What is a geometric sequence? Let's take a look at a few. Here are a few geometric sequences. Let's see if we can figure them out. Okay, in the first one we have 2 and then 4 and then 8. So it looks like they're doubling. So 2, 4, no 6, 8. So we're doubling. The next one should be 16. And then after that, 32, 64. In the second one, we see that negative 3 becomes 9 and 9 becomes negative 27. So we multiplied by 3, but not just 3. We because they're alternating negatives, we multiplied by negative 3. So to get to the next one, I need to multiply negative 27 times negative 3, which would be positive 81. And then I multiply that one by negative 3, so it'll be negative 243. In the last case, the numbers are getting smaller. So 9,000 became 300, 300 became 10. So if we follow this pattern, it looks like we're dividing by 30. So 9,000 divided by 30 is 300. 300 divided by 30 is 10. So 10 divided by 30 is 10 over 30, which is the same as 1/3. And 1/3 divided by 30, well, I'm going to do that over here because I can't do it in my head apparently. So 1/3 divided by 30 is the same as 1/3 times 1 over 30, so 1 over 90. So the next one is 1 over 90. And then that divided by 1 over 90 divided by 30 is the same as 1 over 90 times 1 over 30, so 1 over 2700. So they're getting very small very quickly. Alright, now going back to the top, we're going to talk about what A and R is. Well, A is the same thing that it was for the arithmetic sequences, but now we're in geometric, and it's the first term. So the first term in the first one would be 2. The first term in the second one would be negative 3, and the first term in the third one would be 9,000. The R value is what it's being multiplied by every time. So in this case, we multiplied by 2 every single time. So our R value is 2. In the second case, we multiplied by 3 each time, but we actually multiplied by negative 3 every time. So the R value is negative 3. In the third one, we divided by 30, which, as you can see over here, dividing by 30 is the same as multiplying by 1 over 30. So our R value would be 1 over 30. That's it. So I've rewritten the sequences from the previous page on this page because I want to talk about what the general term is for a geometric sequence. As you have noticed, a geometric sequence then is a sequence of numbers that goes up by the same amount, but you're multiplying this time, not adding like with the arithmetic sequence. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Negative 3 times negative 3 is 9, 9 times negative 3 is negative 27, negative 27 times negative 3 is positive 81. So in each case, we know our A and our R. If we know the A and R in each sequence, then we can come up with the general term Tn. So I'm going to do that beside here. So this one, Tn is equal to the A, which is 2, the R, which is also 2, and the exponent n minus 1 is on the 2. It's on the second 2. For this next one, it's A is negative 3, and then R is also negative 3. Interesting how we have A and R the same in both of those, to the n minus 1. And then finally, this general term would be T to the n equals, take the A value of 9,000, and then R is 1 over 30, and that's to the n minus 1. That is the general term for each one of those sequences. So if I wanted to find the 10th term in a particular sequence, say this one, then I would put 10 minus 1 up here, so 2 to the 9, figure that out, and then multiply it by 2, because of course we have to do exponents before we can do multiplication. So let's continue. Determine the general term for the geometric sequence in which the first term is 144 and the second term is 36. So 144 became 36 because I divided it by 4, Or remember, if division by 4 is the same as multiplying by 1/4. So we multiplied this by 1/4. So a then is the first term, 144, and r is what we multiplied by, so 1/4. The general term that I need to figure out then is t to the n, then my a, so 144, then my r, 1/4, and then n minus 1. That is the general term for this sequence. For this page, you must figure out what the general term is. So you will need your a, you'll need your r, and then you'll just type them into this formula. So t to the n equals whatever a is, whatever r is to the n minus 1. Now some of these are not geometric, so just keep that in mind. Remember, geometric means it has to go up by the same amount. So it has to be multiplied by the same amount every time. So for instance, in number 3, 4 times 4 is 16, but 16 times 4 is not 36, so this is not geometric. It has to be the same amount every time, multiplied by the same amount every time. On this page, you're being asked to find the first 5 terms and the 8th term. So for number 10, for instance, t1 is equal to -4, 3 to the n minus 1, so 1 minus 1. So this answer is -4. t2 is equal to -4, 3 to the 2 minus 1, which equals -12. t3 equals -4, 3 to the 3 minus 1. 3 minus 1 is 2, so 3 squared is 9. -4 times 9 is -36. And then you'll continue and find your t4, t5, and the 8th term as well. Good luck. Okay, so I need to find the 8th term, but I've been given these two terms. I'm going to use the AR to the n minus 1, and I set up these two already. So t5, sorry, that's actually should be a 5 there. t5 is equal to AR to the 4, because it's 1 less than, equals 768. That comes from this piece of information. This piece of information gives me that the second term is equal to AR to n minus 1, so 2 minus 1 is 1, and that's 12. Now I'm going to treat this like a division, and I'm going to actually divide these terms. So AR to the 4 divided by AR to the 1 gives me r to the 3 equals 64, which means if I take the cube root of 64, that gives me 4. So r equals 4. Now I need to find a. If I put in t2, again, if you recall, was AR to the 1, and it's equal to 12. And a, we don't know, but r is 4 now. We know that equals 12. So a times 4 is 12, so a must be 3. Lastly, we need to find t8. I'm going to change back to blue. t8 is equal to AR to the 7. That's just based on the formula. So t8 equals a, which is 3, and r, which is 4, to the 7. I need to do the exponent first, so it'll be 3 times 4 to the 7. Plug that into my calculator, and I got 16,384. And when I multiply it by 3, I get 49,152. So the 8th term in the series that starts with 3 and goes up, is multiplied by 4 every time, ends up being 49,152. I'll let you try the other problems on this page. Here are a few more problems for you to practice. You complain that the hot tub at your resort is not hot enough, and the hotel tells you that they will increase the temperature by 10% every single hour. If the current temperature of the hot tub is 75, what will the temperature be after 3 hours to the nearest tenth of a degree? So we need to know what A is. A is the initial value, so 75 degrees. We need to know what R is. R is what it's increasing by every single time, and it's 10%. So 10% is it's increasing by 0.10 every time, but we need to include the original 75. So it's actually 1.10. So R is 1.10, and N will be 3, because we want to know after 3 hours. We're going to plug these values into our formula. So T3 after 3 hours is 75, 1.1 to the 3. And just plug that into my calculator and figure out what that is. So the temperature after 3 hours will be 99.825, or to the nearest tenth it says, so 99.8 degrees Fahrenheit. Okay, so try some of the questions in this file, and then move on to Go Formative to do your assignment.